So let's go ahead and get it started. Today we are going to talk about the leveling. One of the most important process in surveying is leveling, through which many constructions operation is going to be implemented using the leveling process. So first, what does it mean by leveling? But before that, in this lecture, I'm going to give you introduction about leveling, what does it mean, and the application for the leveling. Then we are gonna introduce very important definitions you should know about it. Then we are gonna talk about the equipment that should be used in order to perform leveling. Then we are gonna talk about the principles of leveling, and also we are gonna discuss the what so-called differential leveling. And finally, we are gonna talk about the Hight of collimation method. We have two main methods in order to perform the leveling. One of them is the Hight of collimation method. But before that, first we need to understand what does it mean by leveling. Remember last time we talked about the different type of distances. We have the slope distance, we have the horizontal distance, and we have the vertical distance. So the leveling is the name given to the process of measuring the difference in elevation. So you have point A and point B. If you are going to determine the difference in height or in elevation, we call this leveling. So you could say that leveling is a process of measuring the vertical distance. This one, the vertical distance between 2 points. Okay, below, on, or above the ground. If you have 2 points, okay, in order to determine the vertical distance between them or the difference in elevation, we call this process leveling. And leveling has many applications, and it's a vital operation in producing necessary data for mapping, engineering design, and construction. So the leveling process is very important. The data that we gather from leveling is going to be used in very important process in mapping, construction, and engineering design. So the result from leveling is going to be used in design highways, railroads, canals, sewers, water supply systems, layout construction projects according to plan elevations, calculate volumes of earthwork and other materials. And also we are going to use the results from leveling in order to investigate dronic characteristics of an area. And also we are going to use the leveling results in order to develop maps showing general ground configuration. So that is why the leveling process is very important. Okay, so leveling is one of the most important processes in surveying. We said that in the leveling we need to determine the vertical distance, right? The difference in height between 2 points. But for example, here we have the Earth. Okay, here we have the surface of the Earth is here. Then, if I ask you a simple question, would you be able to determine how tall is that mountain? If you are going to say the height of that mountain is 1 meter. So what does it mean? Does it make sense? Because I'm going to ask you about the reference. 1 meter from what? Okay, so you need to have a reference. If you are going to measure a height of something, you need to have a reference for that. And the most used reference is the sea level. So we are going to measure the height of objects on the surface or under the surface using the sea level. So the sea level here is going to be 0. Everything above the sea level is going to be positive. For example, positive 2, 4, and so on. Everything below the sea level is going to be measured in negative sign, -2, -4, and so on. So the sea level has been chosen to be the reference for your measurement. When we say that the height of the mountain is 10 meter, that means 10 meter above the sea level. If you are going to say that I have a valley, the depth of the valley is -10, that means minus 10 meter below the sea level. So the sea level is my reference. Okay, so this one is the reference, and the typical elevation of a land between 0 and 1 kilometer. Okay, and for the elevation for the typical depth of ocean between 4 to 5 kilometers. Okay, and the highest point in the mountain Everest, one known. Okay, the point is 8,850 meter. This one is the highest point on earth. This one here is the highest point on earth, and the lowest point on earth is the Challenger Deep in the Mariana Trench. Okay, at the Mariana Trench here we have the Challenger Deep. This one is the lowest point on earth. This one is 1134 meters. 11,034 meters. So here is the lowest point on earth, and this one is the highest point on earth. The reference is the sea level. Now we need to talk about very important definitions that we are going to use a lot in order to understand the leveling. Okay, so here assume I have point A, B, C. Those are points located on the surface of Earth. First, we have the definition of the datum. When we say datum, datum is any reference surface to which the elevations of point are referred. So if you are gonna, for example, for instance, if you are going to determine the elevation of point A, then I need to have a reference for that. Okay, we call this datum. And the most commonly used datum is the mean sea level, MSL. So here we have the mean sea level, MSS. Here is the most used datum. So datum is a reference to your measurement. Okay. Then we have the vertical line. The vertical line is a line from the surface of the Earth to the Earth's center. So if you are going to draw vertical line from that point to the center of the Earth, we call this vertical line of the point A. Also, the vertical line of point C is going to be a line from the surface here to the center of the Earth. Also, similarly for the point C. This is known as the vertical line. Also is referred to as plumb line or line of gravity. Also, we have a level surface. A level surface is a curved surface parallel to the mean surface of the Earth. So, for example, if you want to know the level surface of the point A is going to be a curved surface parallel to the mean sea level. So, for example, the level surface for the point A is going to be a curved surface parallel to the MSL. Similarly, for the point C, the level surface for the point C is going to be parallel to the MSL. Finally, the level surface for the point B here is going to be a curved surface parallel to the MSL. Okay, so now we understand three main definitions. Also, we have the reduced level, RL. A reduced level of any point is its height above or below a reference datum, which is the MSL. So, for example, if I'm going to ask you, what is the reduced level of the point A? So this one, or let's say that for the point C, is going to be the distance, okay, from the point C to the mean sea level. Of course, this one is going to be to go through the vertical line. Also, the reduced level for the point B is going to be the distance from the point B to the MSL. And similarly, for the point C, the reduced level of the point B is going to be the distance from the point B to the MSL. And this one should go through the vertical line. Remember, we defined the vertical line earlier. So this one here is going to go through the vertical line. So when we say reduced level of a point, it's mean that the height of that point above or below the MSL. Of course, sometimes the points could be under the MSL. And now, if I want to determine the difference in height between point A and point B, it's simply the reduced level of the point A minus the reduced level of the point B. So if you want to get the difference in height between 2 points, then you need first to know the reduced level of the first point and the reduced level in the second point. The difference between them represent the leveling or the differential leveling between 2 points, or the difference in elevation between the 2 points. Also, we need to understand what does it mean by benchmark, BM. The benchmark is a permanent point of known elevation. Because, for example, if you want to measure the height of a mountain, then I need to take the MSL as a reference for me. And we know that the main sea level is not going to be close for me in most cases, right? So here, for example, I need to determine the level of one of these close mountain to us right now, but the sea is away from us. So that is why the benchmark has been created. The benchmark are points with a known elevation, just like point distributed for any city, okay, with a known elevation. So your measurement, you're gonna depends on this point in order to know the height of the mountain, because I need to have reference point. Okay, so we call this benchmark. So a benchmark is a permanent point of known elevation. Also, we have temporary or transferred benchmark, TBM. Okay, those are marks set up on a suitable points near construction sites. Again, the benchmark also, they may be away from you. You are making construction site, and then you need to have a reference point. So in this case, you need to work with a point with known elevation which is close to the construction site. We call this point temporary benchmark or transferred benchmark. Okay, so those marks are marks set up on stable points near construction sites to which all the leveling operations on that particular site will be referred. All the measurement in that construction site is going to be referred to the temporary benchmark. Okay, so we have benchmark and we have temporary benchmark. We need to differentiate between them. In order to understand the leveling, we need to understand these 6 main definitions. We have the datum, and we say that the most commonly used datum is the MSL. We have the vertical line here, and we have a level surface, and we have the reduced level of a point, and we have the benchmark, and finally we have the temporary benchmark. It's very important to understand these terms. In order to understand the leveling process, the equipment used in the leveling process comprises levels and graduated stuff. In order to perform leveling, you need to have level instrument, look like that, just like a strong microscope. The level instrument is just like strong microscope, okay, and it's going to be fixed on tripod, okay, and we use these screws in order to make sure that the line of sight is perfectly horizontal. And at the other side, I need to have staff, graduated staff. So through this staffs, you are going to get your readings, okay? And I'm going to show you how we can read this, okay, in the next lectures. And also in the field, we'll be able to use and understand, we're going to be able to use this device and also how to get the reading. So in order to perform leveling, I need to have levels, this level instrument, and also I need to have graduated stuff. These are the main equipment in the leveling process. So what does it mean by a level instrument? A level consists of a high power telescope. So this one, in a simple word, this one is a high power telescope. You know the telescope. And the level is attached to a spirit or bubble level. So here we are going to have a bubble level or a spirit level. The purpose of this one help us to keep the line of sight horizontal. When this bubble is exactly at the center, it means that the line of sight of the device is horizontal. Okay, it's very important for the line of sight to be horizontal. If it's not horizontal, then you are not going to be able to measure the vertical distance. So the device is just a high power telescope, and we have a bubble attached to the device in order to help us to make the line of sight horizontal. So an instrument is leveled into horizontal position by means of spirit bubble, this one or that one, like that. So here we have the device. We have eyepiece focus. We're gonna look from here, okay? And I have the object lens, and you have the line of sight. So the line of sight is going to be parallel to this point here. It's going to be exactly at the middle. Here we have objective lens focus. You can focus on the target using this, and we use this screw here for horizontal motion. After you get the target, then in order to get exactly at the middle of the staff, you need to use the horizontal motion. The motion is you are going to move the device in horizontal, but in slow motion. We have the leveling screws through which you will be able to make the level perfectly horizontal. Okay, here we have the circular level bubbles. We'll talk about this. We use this one also to make sure that the line of sight is horizontal. Again, in the field, we are going to use all of this. You are going to learn how to use the device. Okay, it just to know the main part in the level instrument. But when you get to the site, you will be able to use this device. The instrument needed to do leveling. First, we have the level instrument. This one is a telescope. This one it could be automated levels, or it could be digital levels. So what's the difference between them? If you are gonna use the automated level, this one is easy to use and it does not require any power, not like the digital level. You need to have a battery. And also this one need experience. So you need to have a prior experience before using this one. And the good thing about the automated level is robust even in a hostile environment. So even if you are working in a bad weather, then the performance of the automated level is going to be good. On the other hand, we have the digital level. This one is a push bottom technique, which means that you need to see your target and click on the device so that it can catch the reading. And since this one is a digital level, which means that no reading errors. And we need to have special stuff, not like the normal stuff. Okay. And the readings are stored and analyzed digitally. All the data is going to be stored here and analyzed digitally. So we have the automated level and we have the digital level. In the lab, we are going to use the automated level because this is a must to use one. Then we have the tripod. This device, you need something which is adjustable, help you to get the reading. That is why we need to have tripod. So this one is a tripod. Here it could be adjusted. It could be this low or it could be this high. And it's made either from wood or from aluminum. Okay. So you can put it here, here, anywhere. It's adjustable, help you to get a good position. Also, we have the staff. We talked about the staff. So in the process, I need someone here with a device, and the staff, it should be placed on the point which we need to know the elevation. So the staff is going to be placed on a point where the elevation is needed. Okay, and it's graduated like this one here. Also, we're going to talk about this. The staff is going to be either made from wood or from aluminum. Sometimes the wood is going to be made from invar. This one, in case that you want to have high precision leveling. Also, we have the change plate. This one's going to be placed on the ground in case that the ground is not stable. Sometimes the ground is not stable. If you are going to place the stuff on the ground, then the reading is not going to be stable. So we are going to use the change plate. This one is going to be placed to the ground, and then I'm going to put the stuff above it. Okay, so the plate is firmly embedded into the ground to stop the stuff from subsiding. So this one is not going to tittle. Also, we have the ball staff bubble or the ball eye. This one here, we know you need to understand this. The staff should be put upright. So this one should be put upright. So in order to make sure that the staff is perfectly upright, you are gonna use this pull staff. When the bubble is in the middle, it means that the staff is perfectly right. Okay, because if the staff is going to tittle, then the reading is going to be affected by this. Okay, that is why this one is important for you. It's important the staff is to be perfectly vertical. Finally, we have the marker. Okay, you need to have some location with the markers so that when you finish your leveling and you come back, you know your locations. And in order to do this, the material with which we need to make the marker, it should be of a good quality. It should be long term, should last for a very long time. It's preferable to be embedded in the bedrock or the settle building or bridges. It's not preferable to use fences or walls because this one is easy, can relocate it. So the marker should be placed and at a stable position, like this one, like that one, like that one. If you are going to see new area for new residential area, which was planned for people to relocate after maybe 1 year or 2 years, you're gonna find these markers all over the areas. So these markers here is going to help us to know the level of these important corners. Okay, so in order to do leveling, I need to have the level instrument. I need to have the tripod, and also I need to have the staff. And sometimes we are gonna attach it with the plate so that the staff is not going to tittle. Then the person here, we said the level instrument is a telescope, right? So this one is going to magnify the reading here. So on this device, you are gonna see the crosshair here of this device. So we need to get the reading that corresponding to the crosshair of the device. So one is going to place the staff, and he should make sure that the staff is upright, and another person here should get the reading. Okay, this is how the leveling is going to take place for 1 point. So here we have the staff. So how we can read the staff? The 0 mark is at the bottom. So at the bottom of the staff here we have the 0. Then we have the readings. The readings here, these numbers is going to be in decimeter. So if the crosshair is here, okay, or assume that for simplicity, the crosshair is here at this level, then that it means that the leveling reading is 14 decimeter. Okay, if you want to convert this to meter, you need to divide by 10. This represent 1.4 meter. Okay, if you wanna convert it to centimeter, you need to multiply by 10. So this one, 140 centimeter, and so on. So let's see how we can read the stuff. Of course, here is a view from the one who is handling the level instrument, who is gonna read the stuff. So assume the cross line is here. So first at this point, I have 14 decimeter. The distance from here to here represent 1 centimeter. And the distance from here to here represent another 1 centimeter, and so on. So the distance from here to here represent 10 centimeter. Now, what about the distance from here to here by millimeter? The distance from here to here by millimeter is 10 millimeters. And of course, I'm not going to be certain about the reading here, so I need to estimate. I need to estimate the reading of the millimeter. So if the cross line are located here, then the reading is gonna be 1.422 meter, which means that first here is 1.4 meter or 14 decimeter. Then here I have an additional 1 centimeter and an additional 1 centimeter, which means that I have 2 centimeter. Then I have this distance. I need to estimate this distance, and it has been estimated by 2 millimeter. Okay, so here represent the meter, this one represent the decimeter, and this one represent the centimeter, and this one represent the millimeter. If you wanna put this in decimeter, then it's going to be 14.22 decimeter. Here we have 14, then we have 1 centimeter, another centimeter, which means that I have 2 centimeter, and here I have 2 millimeters. This part need to be estimated. If you want to read this by millimeter, it's going to be 1422 millimeter. So you can read it like that, or like that, or like that. Of course, when you get to the field, you are going to make practice, and you are going to master this. So now we need to talk about the differential leveling, the leveling process. Remember, we introduced to you the term benchmark. And we say that the benchmark is a permanent point of non-elevation. And the benchmark is distributed over the cities and over all over your country. So they are going to be located like that. Okay, whenever you see mark like that, this one represents a benchmark. So why we need a benchmark? Remember, we say that the main sea level, the MSL SL, is our reference, and we do the purpose of the leveling in order to know the elevation of a point. Let's assume that I need to know the elevation of the point B, the reduced level for the point B. The sea is going to be away from me, so it's difficult for me to take the reading according or with the reference with the mean sea level. That is why the benchmark is located here. The benchmark is going to be close to me, okay? Not like the MSL. That is why we distributed a lot of points for the benchmark. So the benchmark is important because in order to know the level of this point, I need to have a benchmark for me. Okay, without a benchmark, you're not going to be able to know the level of that point. So the benchmark represents the reduced level of that point. So let's say the benchmark here is 100 meter. It means that the level of that point is 100 meter. Okay, so in order to do leveling, okay, I need to have benchmark. Without the benchmark, you're not going to be able to know the elevation of unknown point. Then we have something called backside. So now it is very important to understand these type of sides. We have 3 main sides. We have the backside, we have the foreside, and we have the intermediate side. First, we have the backside. When we are going to determine the elevation of the point B, we said that I need to know the benchmark, right? So the benchmark is a point with a known elevation. When I say this point is a benchmark, It means that I know the elevation of that point. So now I need to place the instrument between the benchmark and the point B, the point that I need to know its elevation. Now I'm going to install the device here. Then I'm going to place the staff at the benchmark. And then I'm going to get the reading. Okay. We call this reading backside. We call this reading backside. So why we call it backside? Because the staff is placed on the benchmark, and the benchmark, the point, the elevation of the benchmark is known. When we place the staff on a point where the elevation is known, we call this backside. So the backside is defined as is a site taken to the graduate staff. This one is a graduated staff at a point of known elevation. It could be benchmark or it could be temporary point. The point is when you place the staff on a known point, we call this backside. Then I'm going to place the staff on the point which I don't know its level. And I'm going to get the reading. We call this foresight. So the foresight is a site taken on any point to determine its elevation. So when you place the staff on a point that needed to know its elevation, then we call this foresight. Where the backside, remember here, don't get lost. The backside here, we place the staff on a known point, which is a benchmark or temporary point. While the foresight, we are going to place the staff and get the reading for a point we need to know its elevation. Now, please focus here. We have the last side. The last side is the intermediate side. So now I need to know the elevation of the point B. But sometimes I need to know the elevation between the benchmark and between the point B. So assume that I need to know the elevation of that point or the elevation of that point. In order to know the elevation of this point, also I need to place the staff here and get the reading. And also I need to get the staff here and to get the reading. So this point, we don't know its elevation. We need to know its elevation, right? We call this intermediate side. And this one is similar with the foresight, except that the foresight is the last reading. The foresight is the last reading before I move the instrument. So it's very important difference between the intermediate side and the foresight. For the intermediate side and for the foresight, the staff is going to be placed on a point we don't know its elevation. We need to know its elevation. Okay, but the foresight is the last point after which we are going to move the instrument. So this one is the last point. So the difference between the foresight and the backside, the foresight is the last site taken before the level instrument is moved to another location. This one is the last point, where the intermediate site is going to be a site is going to be taken between the backside and between the foresight. So now we have three sides. We have first the backside. The backside is going to be placed on a point with a known elevation. Then we have the foresight. The staff is going to be placed on a point with unknown elevation. And this one is the last side for us. While the intermediate side, we are going to we are going to place the instrument on unknown point. But this point between the backside and the foresight. So the intermediate side and the foresight, they are similar, but the foresight is the last reading after which we are going to move the instrument. Whereas the intermediate side is going to get the reading for a point between the backside and the foresight. So now, in order to know the leveling, I'm gonna use these three sides, okay? But we have two methods in order to determine the elevation of unknown point. Now the task is to know the elevation of this point here. In order to do that, I have two methods for obtaining the elevation for a point. First, we have the height of instrument, or sometimes we call it plane of collimation method. And also we have the rise and fall method. In today's lecture, we are gonna introduce to you the height of instrument method. In the height of instrument method, this method consists of finding the height of instrument. We are gonna talk about what does it mean by height of instrument for every setup of instrument. And then obtaining the reduced level of a point. Remember, the reduced level is the level of the point with the reference to the MSL. Then, after we understand the height of an instrument, then we are going to introduce to you another method, which is the rise and fall method. And this method consists of determining the difference of a level between consecutive points by comparing each point with intermediate preceding point. So after we finish from the height of an instrument, we are going to talk about the rise and fall method. So now I'm going to introduce to you the height of instrument method. Now we need to know the elevation of the point B, right? The task is to know the elevation of the point B. So in order to do that, I need to have a reference for me. This time the reference is a benchmark, right? So the benchmark, the point A represent a benchmark. The benchmark for the point A represent the reduced level of the point A or the elevation of the point A. So the benchmark, if the benchmark 100 meter, it means that the elevation of the point A is 100 meters. Then I'm going to place the instrument between the benchmark and between the point B. Point B, we don't know its elevation. We need to determine its elevation, right? So the first step, I'm going to place the staff on the point A, and I'm going to take the reading. So this reading, we are going to call this reading backside, because we placed the staff on known elevation. So this one is going to be recorded as backside. And this line is the collimation line. Of course, the instrument, when you install the instrument, you are going to make sure that the side here is going to be perfectly horizontal. Then the reading here is going to be recorded as a backside. After that, I'm going to place the staff on the point B. The point B is unknown elevation, right? The elevation of point B is unknown. Then I'm going to take the reading. Again, the reading is going to be perfectly horizontal. So this reading, we are going to call this reading foreside. So this one is a backside, and this one is the foreside. Now I'm going to introduce to you what does it mean by height of instrument. We call this method height of instrument, right? So the height of an instrument represent the distance between the MSL, the main sea level, to the line of sight. We call this line of sight or collimation line. So the distance between the line of sight to the MSL is the height of instrument. So now, how to determine the height of instrument? From this picture here, from this figure here, we know that if this one is the height of an instrument, which means that this also from here to here is the height of instrument. So from this figure, the height of an instrument equals the benchmark, the distance from here to here, plus the back side, right? So the height first of point A represent the benchmark, right? We agreed on that. The height or the elevation of the point A represent the benchmark. And the height of an instrument, the distance from here to here, it will be the elevation of the point A plus the back side. So now the height of an instrument is going to be the height of point A plus the back side. Now, in case that I need to know the elevation of the point B, remember the distance here is the same as the distance there. And we already got the foreside. So in order to get the elevation of the point B, which is the distance from here to here, is gonna be the height of an instrument minus the foresight. The height of an instrument, this one here, minus the foresight. Okay, this is going to give me the height of the point B, or the elevation of the point B, or the reduced level of the point B. This is how the height of an instrument method works. It works like that. I need to know the height of an instrument. The height of an instrument represent the benchmark here, or the height of the point A, plus the backside. Then the elevation of the unknown point, which is point B in this case, is going to be the height of an instrument minus the foresight. So this is the process for the height of an instrument method. So again, first I need to determine the height of an instrument. The height of an instrument is going to be the known elevation, which is the benchmark, plus the backside. The backside is the reading on the benchmark. Okay. Then the height of an instrument known as HI, and the elevation of the point, the known elevation is going to be elevation of point A, for example, plus the backside on the point A. Then the new elevation, which was the elevation of the point B in the previous example, is going to be the height of an instrument minus the foresight on the new point, point B. So we are going to say that the elevation of point B is going to be HI, the height of an instrument, minus the foresight. This is how the height of an instrument method work. Okay, so let's see example if it's possible. We need to solve example, or before that, I'm going to solve the example, and then I'm going to get back to arithmetic check. The arithmetic check is a method to help us to know that whether my calculation is correct or incorrect. Okay, after you finish your calculation, then you are gonna make arithmetic check. Arithmetic check help us to know whether my calculation is correct or incorrect. But before that, I'm going to show you this example so that you can understand the idea perfectly. So here we have this example, example 1. In this example, we need to know the elevation of point B. So here we have point B. We need to know the elevation of the point B. Of course, all my measurements is going to be made with the reference with the reference to the MSL. But we know that this is not possible. That is why we have benchmark. So I need to look for benchmark. Now I find point A. Point A is a benchmark, and the benchmark is 100 meter, which means that the elevation of point A is 100 meter from here to here. Then I'm going to place the instrument between the benchmark, and the benchmark here is a point A, and the point B. Of course, we don't know the elevation of point B. That is why we need to do the leveling. And here we are going to use the height of instrument method. So what I will do, I'm going to place the instrument here between the known point and unknown point. Then I'm going to place the staff on the point A. We know the elevation of point A. So the reading here, the reading which is going to be taken here, we call this backside, right? So the reading came out to be 1 meter. And the elevation of point A is 100 meter. Then I will be able to determine the height of instrument. The height of an instrument is the distance between the line of sight to the MSL. So the height of an instrument in this example is going to be 100 meters plus 1 meter, right? Which is 101 meters. Now, I know the height of an instrument. Then I'm going to place the staff on point B. The point B, we don't know the elevation of point B. So when we place the instrument on point B and we get the reading, we call this foresight. And the foresight came out to be 4 meters. So now how to determine the elevation of the point B? According to the height of an instrument method, first I need to determine the height of an instrument. The height of an instrument came out to be 101. Then the elevation of that point here is going to be the height of an instrument minus the foresight. And the height of an instrument minus the foresight came out to be 97 meters. So now the elevation of point B is 97 meters based on the height of instrument method. This is how it works. So now let's get back to the arithmetic check. So we say that in order to make sure that my calculation is correct, I need to do arithmetic check. So in the arithmetic check, you can see here delta H. And if you are going to draw horizontal line here and horizontal line there, you are going to figure it out. The delta H is a difference between the height of point A and the height of point B, or the elevation of point A and the elevation of point B. So delta H, this distance here, is the height or the elevation of point B, this distance, minus the height or the elevation of the point A. So delta H equals HB minus HA, or the reduced level. Remember, we introduced to you the reduced level. The reduced level is the elevation of the point or the height of the point with respect to the MSL, the distance from here to here. So you could say that HB minus HA, or the reduced level of the point B minus the reduced level of the point A. And we said that the backside, this backside here, if you are going to draw horizontal line here and horizontal line there, the backside, this distance is equal to the foreside, the distance from here to here, plus delta H, right? From this figure, we can say that the backside equals the foreside plus delta H. Of course, it could be plus or minus, depends on whether this elevation is higher than this elevation or lower than this elevation. And the delta H, this one, represent HB minus HA. So this one is going to represent HB minus HA. In this case, we have plus the backside equal the foreside plus delta H. In other cases, the backside is going to be the foreside minus delta H. But in this case, we have plus. So instead of delta H, we are going to substitute by HB minus HA. So take Fs to the left-hand side, then the backside minus the foreside is going to represent HB minus HA. So the difference between the foreside and backside and the foreside is the same as the difference between the level between point B and point A. And in order to make a check, then we are going to say that the summation of the backside minus the summation of the foreside should equal the last reduced level minus the first reduced level. So after we finish from the process of height of an instrument, we need to make this check. Okay, when we solve example, this one is going to be more clear for you. So let's see here, we solved this example already. We determine the value of the point V, right? So we could also make a check here in this example. You need to the value of the backside, here came out to be 1 meter, right? And the value of the foreside came out to be 4 meters. So the difference is 3 meters, right? So this difference should be the same as the difference between the point A and the point B. The level of the point A is 100 meters, and the level of the point B is 97 meters. So now the difference between them is 3 meters, which is the same difference between the backside and the foreside. Okay, so after you finish from your calculation, you need to make a check by using the arithmetic method. So next time we're going to talk about the turning point. First, I'm going to just give you an introduction about the turning point. Sometimes I need to, for example, if I need to know the elevation of the point B, the distance is far away between point A and point B. So if you are going to place the instrument here, you are not going to be able to see the staff at point A or the staff at point C. In this case, I have a problem, right? The distance is too far. I cannot see the staff here or there. So in this case, I need to create a turning point or temporary point to transfer the elevation. So I'm going to create a point here through which I'm going to transfer the elevation from this point to that point, so that when I'm going to place the instrument here, I will be able to see the staff at this point and the staff at that point. So this is the situation. Sometimes you are not going to be able to see the point A or point B. In this case, I need to create the turning point or the temporary point to transfer the elevation from the benchmark to that point. So first, I'm going to place the instrument here. I'm going to call this setup 1. So in the setup 1, I'm going to place the instrument between the benchmark and the temporary point. Then I'm going to get the backside. I'm going to get backside here, and I'm going to get foreside here. Then I'm going to determine the height of an instrument. Then I will be able to know the elevation of that point. Then I'm going to relocate the instrument from setup 1 to setup 2. Okay, because for me now, the turning point is the new benchmark. I managed to convert the turning point to be new benchmark. Now I'm going to have setup 2. I'm going to place the instrument here. Then I'm going to get the back side, and I'm going to get the foreside, and then I'm going to be able to determine the elevation of this point. And this process, it could be done more than one time, numerous times. If the distance is too far, maybe I'm going to have 10 setup, 20 setup, until I get the point which I need to know its elevation. Okay, so in this example, it was very simple. I have only one setup. But like I said, sometimes the distance is far away, so I need to create more than one setup so that I will be able to reach this point. Okay, so I'm going to stop here. So next time I'm going to show you example in case that we used turning point. So here, this example, we use turning point. So I'm going to have 2 setups so that I will be able to reach the station C. And in this case, I'm going to do the height of an instrument method 2 times. I'm going to apply it here, and then I'm going to apply it there. So we are running out of time. I'm going to stop here so that if you have questions need to be answered, I'm here to answer.